We saw on the first part of the lecture, we saw how functional programming, some tenets or ideas from functional programming. We also saw how some of the ideas are applied, pun intended, in Python. For example, filter, right? We supply, the basic idea is we use these functions as first-class citizens, meaning we pass them as variables, right? We make them do. We apply them basically, right? So in here, filter, right? We can use this to maybe simplify code in some cases, right? Again, we supply a function which is supposed to give you a Boolean value, true or false, right? And we can filter out some results. There is a related function, just as widely used, called map function. Again, you may have used this in JavaScript, use them maybe in Scala, right? So idea is map, using map function, we supply a function that creates a transformation. I don't want to type everything myself. I'll let the right. We supply a function that takes an argument and an iterable. Right. The map function applies the function to each element of the iterable, and we get out the new iterable. So let's take something simple, like something like double. Let's define a double function. Right. Something stupid. Right. So, right, again, pure function, of course, naturally we want a pure function, right? No side effects, no sir, right? No side effects, okay? And then we have some numbers. We still have the numbers, right? We have the numbers, right? So, double numbers, again, double numbers, list map, double numbers. So each number in our list will have the map function applied, and then we'll return a new list. Again, same thing as before. Again, note, we have to use list to instantiate the map object because it returns a map object which can, I think it returns, what does it return? Iterable. It returns a map object, which is generator. So we can use not a list again. Map is because we might want to have want to chain, as long or use it with filter. Okay. Now, so let's print out double numbers. You're not going to be surprised that double numbers are actually double numbers, right? So we have 0, 2, 4, and so on, right? So again, of course, again, we could have used list comprehension, right? Also double numbers, and of course, and we can use regular iteration, of course, right? So, right, and of course now, right, so which one to use, right? Speed-wise, I believe list comprehension is a little bit faster, right? The mapping is going to be, again, so map will be better if you use chaining. So which one to use, right? So choosing right map function, right approach. Well, so when would we want to use map in Python? So we want to chain multiple, that's right. Of course, but particularly, right. So as of course, concise and also but again, of course, that doesn't necessarily why, right? It's okay just because I want to use functional programming, but more importantly, more crucially, map can be more optimal if you expect to create chain multiple That's the thing is, right? So, so that's what I, right? Super, all right. All right. All right, so that's the approach. Now, so map makes sense. So map, we supply a function, again, right, which does something, pure function. So let's look at one more time again. Again, we do not need to have a function predefined. Yeah, we can use lambda functions, right? So lambda double numbers, we come up with our double function, right, whatever it is, right? Right? And we apply it basically, right? And we create, so of course it's not gonna be right. So again, I like map in general, of course, again, but I'm not particularly a big fan of how, well, the syntax in Python to me just doesn't feel completely natural. So usually I just need a list comprehension is just as fine, right? So again, notice this declarative approach, right? We do something. Now, how about combining filter and map, right? So we want to, well, if we are gonna, yeah, so the order matters, and then we're gonna double them, right? All even numbers and then double them, right? So look, this is how it would work, right? Notice all these parentheses. So even double numbers, we filter out the numbers first, right? And then we double them, right? So again, it's all sort of, we declare what we want to do, right? How it's done, right? The magic of this, well, again, of map and filter, how Python does it, we don't really have to worry. Of course, there's looping underneath hardware level. There's going to be looping involved, right? And if statements for filter, right? But particular details are not so crucial. So this code actually can be much shorter, more concise, right? So this is something like this, right? How would we do this without lambda? So how about one more thing? How about doing it with anonymous functions? Anonymous functions. Right? So we have two lambdas, right? So same thing, right? Filter first. Again, in this case, does the order matter? Of course, order matters. Note order matters. Otherwise, note that order matters. We first filter matter because if we first map, you have double. Then filtering for evens would be useless, right? Since all numbers would be even, right? Because if I double any number, it's an even number, right? But we can try it, of course, right? Let's try it. All right, so hopefully you trust me, right? So results same. Okay, one more thing on the less used is, of course, reduce, right? And this is well, not maybe let use. So you may have heard this map reduce idea. Maybe this is used a lot in parallel computing, mass computing. Basically, idea we can apply, we can map some things, we can create transformer functions. They're easy to do in parallel because we just apply them to everything, right? On oh yeah, actually I was going to say one more trick. Actually, you can do it for lists, but yeah. So we can do reduce, and this is a little bit harder. Reduce I don't like too much myself, but doesn't mean that you shouldn't use it if the tool's right. So let's look at reduce. Reduce in Python. The idea is to, yeah, we have a single list of items, right? We apply a function that takes two arguments and successively applies to the elements of a list. Let's see this in action. So we need a function that adds, let's have an add function, right? Add x plus y, return x plus y, again pure, again pure, again pure. pure, no side effects, of course, and then we apply it. We'll have a reduced function, we'll need to import it. We don't have it, it's not, yeah. Import from, yeah, so from functools, I believe it was, yeah, from functools, import reduce, yeah, it is in the not included by default, you know. So in standard library, yeah, all right, and so then we can use it. Yeah, so we have our numbers. It's what's numbers 1 to 9 is 45, I believe, right? Yeah. Let's see some of numbers, right? Add and numbers. Order matters here, right? We don't, you know, function sequence, right? Right. This you can see actually example exactly, right? So it should be print sum of numbers should be 45, I hope. Right? Yeah, it is 45. Right. So again, of course, here, of course, we did not need it because, of course, here, of course, oops, what did I do here? I did not look for something. Of course, in Python we have built in some function, right? Right. That does the same thing, right? So essentially, right, it does apply successively to this list, the numbers, reduces them one by one by one by one, basically, right? So, so that's something to again, something which will come up again in functional programming. So sum, I mean reduce, apply, unmap, right? Welcome back. Now, right? So reduce in Python. And I think it's time now we saw how Python incorporates these ideas, right? Let's look at something a little bit more closer to a real functional programming language. Python is just, again, partially. You don't have to use the functional paradigms, right? So let's look at Clojure, right? And let me see. So Clojure is a type of Lisp, right? Let me see if I can give you a link. Right, this will be our last thing we'll do today. Yeah, try Clojure. You can guys follow me along, right? And we'll do more of this on a Monday, right? Let me see Clojure itself. Clojure.org, I think it is, like Clojure.org. Yeah. So this is a language we will be looking at next week in more detail, right? So it's a general purpose language, right? So it's basically Lisp. It's dialect of Lisp, right? Just like, you know, so like, you know, Latgalian would be a dialect of Latvian, right? Would that be correct? Yeah, yeah. I was going to give an example, right? So it is predominantly, right? So again, there is some mutability involved, right? So it's the most popular. So this is the only, again, there's some people who like to use Lisp for everything, but Clojure is the only real like practical language in a Lisp, how should I say, ecosystem in a family. Because why? Because you can run Clojure, you can compile it, well, it compiles to Java virtual machine, Java bytecode, so that's a big plus. So you can use just like anywhere if you at work, which use JDK, right, you know, so you can use Clojure. That's why it's so popular, actually, right? Not as popular, of course, not as Scala or Kotlin or Java itself, but this is an option. If you like Lisp, if you learn here, this actually means it gives you a practical pathway, right? So, so let's try it, right? So again, your weekend task will be to install Clojure on your own computer. So how many people have Java installed on their computers? 1, 2, 3. Yeah, you have it. All right. So this means Clojure basically will be really easy to install, you know, to add on top of it. Right. So this will be your weekend task, right? Okay, but let's try it. Let's try this in our sandbox, right? So pretty nice. I really like just, you know, get started basically. And you'll see, get ready for many parentheses. You'll be getting into, when you do Lisp type languages, it's all about parentheses, right? So basic idea is you have, right? Okay, we have supply, let's say again, so plus 10 and 20, right? Something like this. So this means adding, well, right, this expression basically plus on parameters, right? So this is how it's done, right? And of course you'll have 30, right? So the function is plus, right, and has two arguments, 10 and 20, right? How about, what do you think about this? What do you think this will work? 10, 20, 30, 40. What do you think? Works, right? So there are a couple cool things about this, right? So you supply the parameters, doesn't matter how many, right? It's kind of cool, right? So, but let's get started. Maybe I'll make it a little bit bigger. Yeah, a little bit bigger, right? So, again, let's start, right? All right, so, well, of course, we can have some strings, hello, sup, right? But it doesn't work. Well, all right, I need to type exactly. It's case sensitive. All right, hello world. Oh, yeah. Even worse, I need to type exactly, right? Oh, there we go. Yeah, and I need to do exactly, so to trigger it, right? Okay, so Lisp stands for list processing. It's all about lists, right? So it's like the basic computing unit, the data structure, right? So collection of items, basically, right? It's very loosely typed, right? List could be anything, right? Of course, generally you want same types, right? So even though underneath is, of course, JDK, JVM, of course, you have strong typing, right? But here, so how do you create a list, right? So basically, right, this is a list, right? And this is a list of what? Of numbers on a function, right? Right? So how do you create a list? Basically, you put them in parentheses, or you call a list, right? Like this, basically, right? So a list 1, 2, 3, 4, right? Right? Yeah. So you already saw the math, right? So so question is, what happens if I do this? Let's say division 100, 10, and 2. What happens? I don't know. That should be 5? Yeah, it is 5. Right. Right. So Lisp is mostly, almost sure, fully functional. Right. So first argument of a list should be a function. Right. The rest are arguments, basically. Right. So like if I do not true, right? Not is the negation function, true is the argument, right? False. And not true, not false would be true, right? How about and true and true? Can I try to do this? Yes, it works. Or true or false, false, right? False, right? So we applied or to false and false, right? So how about or false and true, right? It will be true. How about and true, 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 false, right? This will be what? False. It is false, right? So, yeah, again, very simple syntax, right? Very, very simple syntax. It's just the way the way of thinking is a little bit different from what we are used to, right? So, but first thing, again, first the function, right? And then you do whatever, right? So my name is Valdis, right? So my function. So these are some of the built-in. Of course, you can imagine these are not part of a standard Lisp. My name is not actually part of standard, right? It's just something for a tutorial, right? And right. So obviously, I'll do Valdis, right? RBS, right? And it works, right? So we're using REPL, right? Interactive computing, right? Read, evaluate, reply, right? So username is a special keyword. It's a keyword, right? So special. So basically, like a variable, basically, right? Special form keyword, right? So username, right? So apparently, the myname function created this, right? It created this username, basically, right? So can I do this? Actually, I wonder what happens if I do this, right? I don't think it works. No, it doesn't work like that. What happens if I do this? No, it doesn't do anything. Yeah, just you have no arguments, right? Again, it's very flexible. I'll do next. So how about? So it doesn't do anything next, right? Yeah. All right. So we create functions for everything, right? Yeah, we can check. We can set. We can set prompt. That's just for REPL, right? Let's do a green prompt, right? And can we do text? Set prompt, right? And color green, right? Let's try green. And I has text. Let's see. Can we do this? Yeah, can we do this? I wonder. Text. Let's do RBS, maybe something like this. RBS. Oh, somebody's calling me. Just a second. Just a second. 1 second. So text RBS. Let's see if this works. I think it will work. Let's take a look. Maybe I want to add some weird errors. Maybe like, can I do this? We'll see. I don't know. Yeah, it works, but it didn't really work. It worked, but apparently, yeah, this is you see, it's of course we're using HTML, right? GT greater than, right? Doesn't work. The green thing worked, but let's do something else. Let's reset this. Right, RBS. I'll reset it. Can I do this? That's RBS. Yeah, now it's better. Right. How about? So that's my prompt. Yeah. So, but of course, this is just for fun, right? So, so we called some functions, right? Let's do some reverse, of course, the famous function, right? So reverse on a long string, right? So let's see what we're gonna replace. Alus re of course, indeed, right? Right, and of course it will. We'll see this will be replaced, right? Let's see what happens. Right. So of course we got a list of number of letters of cars, right? So it worked, right? Of course, pretty big result, right? So again, by now you should be used to having a function, right? And you have some parameters. Notice again, I want to go back to this approach here, right? So here we passed very different type of parameters, right? We had the color, right? Keywords, right? And we also had you know, string literals, right? That's fine, because of course there's going to be some application here, right? So let's do. Okay, so I need to type exactly this. Okay, yeah, type reverse. Let's do one more thing. A long string. We get to arrays and then we can finish, right? A long string. Yeah. All right. Yeah. So some people say you get the enlightenment from this. Actually, there's XKCD for Lisp, right? That it's like the completely change your way of thinking, right? So so vectors are sequential elements, right? So obviously by now from data structures in a classical list, right, you have a linked list. You can go jump next, right? You don't have indexed access, right? That's why you want vectors, because of course they will have faster random access, of course, right? So vectors are easy to create, right? My cats, right? I'll say Vinny, Darcy, and I don't know, Zila. I don't know if this supports Latvian. Does it support? Alt. Let's see. I wonder if it works. What's Latvian? Latvian with. Yeah. Let's see what happens. Yeah, it works, of course, right. So, well, the global variables, we still end up with some global variables, right, in a Clojure, because it's pragmatic, right? So, let's make the variable, right? Let's create foo, and we have dinner. I'll call dinner, right? So the variable foo will have a value dinner, right? Yeah. So there's also local variables. Obviously, why would you want to? Of course, you will want to use as many as possible local variables as possible, right? So let's take a look at this example here, right? So this will probably be our last thing we do today, and then you can have it over the weekend. You can play around with this a little bit more. So let, right? So X will have scope only, lexical scope, right, within this let keyword particular, right? So let's try this example here, right? So let, right? So A and B, right? A being 2 and being 3, right, will only apply to this scope, right? So you notice again this example, right? So we have scope and we pass A and B, right, here. So notice, so of course outside this scope, again we have how many parentheses? Just 2, right? Outside A and B does not exist, right? Which makes sense, right? So we should get 6 back, right? Right. So how about again? I don't know. We'll do keywords later on, right? We'll get that on Monday. So let's not. You can complete the tutorial afterwards, right? But I think you got the idea, right? Again, basic idea: function parameters, right? And let's see about about installing, right? So some people have problems every year, but you shouldn't really have. So I would advise, I guess, let's see which I would apply the long support version. You need, of course, JDK, right? OpenJDK. So 21 actually LTS, right? You want the LTS version, long-term support version. I use the Amazon one, but of course you can use also, there's OpenJDK, right? You can use the Oracle one if you are there, but I probably would not want to use the original or Oracle one. Now, but how to install Clojure itself, right? Installation here, right? Again, so you have you need there's a bunch of books, we don't need too many right now, right? You need the language, you have the REPL, right? But you will want also, again, it will be usually, you will run it against a Java virtual machine, usually. There's also, you can run it against something else, right? So people do it for, some people who want to use Clojure for web development, I mean, you can compile it to JavaScript if you want, but that's usually not, that's less used. So installation, right? So, yeah, Mac, where's Mac here? Any Mac users? Yeah, you can do brew install, or supposedly should use, right? Linux, of course, and Windows, right? But the installer. So what I will do, actually, I will try to do it myself. I will try to install since I'm using Linux, right? Or code space run Linux here, right? I think we can do it. This be kind of, so this should work for everything. Let's see do we have a Java version? I think we do. Yeah, we have JDK 21. All right, so this should be good enough for installing Clojure, right? So we'll do that if you don't succeed, right? We can do that on Monday, right? So again, one way is do it Visual Studio Code with the Calv extension, right? Those who are using IntelliJ, who are using the IntelliJ here? Anyone? No one? No. So yeah, you could use Cursive. There's a plugin, right? IntelliJ is using Java development, right? So, but Visual Studio Code with the Calv extension, it's called like this, Calv Visual Studio Code, right? And looks like this, right? It's just a plugin, right? Where is it? Replit, yeah. Where is it here? No. Oh, there, Marketplace. Okay, there it is. Yeah. Install, right? So you can see there's 180,000, well, probably not all, probably some duplicates, but probably 100,000 people using Clojure. So not with Visual Studio Code, right? Of course, some hardcore programmers, of course, are using something else. So it's not maybe it's not obviously not a Python popularity, but still, you can use Visual Studio Code. A couple of years ago, it was not such a good, you had to do it your own, pretty good plugin, right? So that would be, I think, one approach. There's no one. You could theoretically do nothing, you'll need to complete some, the second homework, right? So you probably want to install it locally. I mean, you could done it on the cloud, like I will do it here, right? You could do it like this with CodeSpace, and it would work, right? We'll see how well it works on Monday. All right, any questions on Clojure? No? So we'll continue on Monday. All right. Thank you, everyone.